System design is not about drawing boxes. It is about making trade-offs under real constraints. When I think about system design thinking, I start with the real job, reviewing a new product architecture while balancing business pressure, deadlines, incidents, and long-term ownership. Before we pick components, be clear about the workload. This design has to handle requirements, constraints, trade-offs, failure modes, cost, operations, and how the system must evolve over time, not just a clean demo request. The first diagram usually looks fine because it only tells the happy path story. For this topic, that naive version is usually a polished box diagram that shows the happy path but hides failure, cost, ownership, and change over time. I still start simple on purpose. The smallest version that can work here is a polished box diagram that shows the happy path but hides failure, cost, ownership, and change over time. That gives the team a baseline before complexity earns its place. Next, I walk one normal request or event through the simple design. That is where the useful questions start, because the path reveals what each component actually owns. The problem is not that the simple version is wrong. The problem is that it ignores what production will demand next. Teams optimize the ideal path and ignore the ugly edge cases that create incidents later. The first production pressure usually shows up here. Teams optimize the ideal path and ignore the ugly edge cases that create incidents later. That is the moment when a pleasant diagram turns into an engineering decision. Then operations gets involved. If the design cannot be observed, rolled out, and recovered safely, the system is already too expensive to own. In this topic that pain looks like operations, observability, and rollout safety stay invisible until the system is already painful to own. And then comes the part junior diagrams almost always skip. Designs that look scalable on slides still fail once costs, blast radius, and team capacity enter the conversation. That is where production-grade thinking separates itself from feature demo thinking. So the better design adds only what solves a real problem. For this topic, that better shape is a design review flow that starts with requirements, traces data flow, surfaces trade-offs, tests failure paths, and checks cost, plus operational reality. This is what you gain from the stronger design. You make faster, safer architecture decisions because every important constraint is explicit. Those gains are why the extra complexity is sometimes worth it. But there is always a bill to pay. The cost of the stronger design is the review takes more discipline because you have to discuss what is awkward, expensive, or still unknown. That trade-off is the real system design conversation. Now I challenge the design with a failure question. Ask what happens when traffic spikes, a dependency slows down, the budget tightens, or the team has to change the design 6 months later. If the diagram cannot answer that honestly, it is not ready. So the final architecture story is simple. Start from the problem, define constraints, test the naive version, add only the components that solve a real risk, and review how the system evolves under pressure. That is the version I would be comfortable defending in a serious review. If you remember one thing, make it this. Viewers understand that senior system design is about judgment, not memorizing patterns. Good system design is a judgment loop, not a memorized answer key.